So if you go on Blackboard under course content, system notes, and whatnot, there are 3 particular links that I highly recommend you just watch and conceptualize what they mean in terms of Fourier transforms, Fourier series, okay? If a particular u of t is not periodic, and you want to write u of t as a sum of constants time e to the I 2 pi ft's for all values, but this u of t doesn't have a fundamental period. Technically, its fundamental period is infinity. So what ends up kind of happening is that you would have to write u of t as the inverse Fourier transform of the Fourier transform of u times e to the I 2 pi ft df. So what does this mean? This means that at a particular unique frequency, this frequency, there's some constant value uf that I can represent u of t. And I'm going to take for all values of f. So that's what I'm integrating over all values of f. That's like saying I'm going to take u0 e to the I 2 pi 0 t. u minus 1 e to the I 2 pi minus 1 t. And all the values in between. So in a sense, this is representing kind of what we're doing over there. We're representing it using the eigenfunction property. So that way, if you have some kind of u, and you write that as the inverse Fourier transform by the value of this u, that is the frequency, the inverse Fourier transform of the Fourier transform times e to I 2 pi ft's over all the values of f. Output y of t therefore has to be u of f times h of f e to the I 2 pi ft df. Just let that sink in a little bit. So this integral is kind of like the summation, but it's taking the summation for every single frequency, not just every frequency of the harmonic. So if your frequency here was f0 was 10, then you do 1 over 10, 2 over 10, 3 over 10, and so on. Here, you have a continuous spectrum of all the frequencies. Go to the links on Blackboard, and then it'll kind of demonstrate how the Fourier transform is kind of different than a Fourier series, and how to like visually look at it. Questions? Questions? This is important.
Are we going to do an example?
I'm letting it sink in a little bit first. It's not. Okay. And just by definition, if you have a signal in time and you want to take the Fourier transform of that, the Fourier transform of that signal in frequency is integral from minus infinity to infinity of the time thing, e to the minus I 2 pi ft dt. Okay? Now, if you have the frequency thing and you want to go back to, if you want to go back to time from frequency, that is big U big U of f e to the positive I 2 pi f t df. Okay? Forward Fourier transform, inverse Fourier transform, just by notation. Someone, what time is it? Good, I am making good time. So I don't quite have a full example. A t s of t e to the minus I. What? Let's say there is a input signal u of t equals e to the minus at us of t. They ask you what is big U of f. Go ahead, just plug it into the formula and get out. So I think I did that over there already, but if the exam question asks for Fourier transform go ahead and just use the formula. And then there is the table Fourier transform table that you should use, and the table has different properties on there. I think question 7 on this homework 3 is pretty mean, and do not do the integral. Do not. I repeat, do not. There's a property that you can use to make things easier. And then I think Parth here can tell us all how to do that if you talk to him individually, right? Yeah. Come to office hours too. We won't give you the answers, but we'll give you most of the way there. Okay. So the last thing that I'm going to talk about real fast is the order of operations that you should think about when you get to a problem. So for an arbitrary input-output system that the system's LTI, you're going to be asked, okay, here's a particular U, how to find the output Y. So the first thing you want to do is, unless you want to do the convolution, or it explicitly tells you to do the convolution, and if it looks like it's a nasty convolution, don't do the convolution. So the first thing you want to do is, can you write U of t as sum of complex, complex exponent, some periodic functions? And in order to do this, you have to ask first, can I write it with Euler identities? If you can't write it with Euler identities, what's the next best thing? Can I find out if it's periodic? If it is periodic, then there's a nice form for this a sub k. That's 1 over t integral of t over 2 minus t over 2 to t over 2. Or 0 to t of this periodic signal t, u of t over the period t e to the minus I 2 pi f0, which is 1 over t. 1 over big T, t dt. So if it's periodic, then find the Fourier series constants. If it's not periodic, then find the Fourier transform. Yep. So that's step 1. Oh, I ran out of board. So that's all. Step 1 is all about writing u of t as a sum of complex exponents, sum of periodic functions. To find the rest of it, to find the output y, you have to then know what is the system frequency response. H of f. And you can get H of f by several ways. I did that at the beginning of this. You can say, okay, for the simplest complex exponent, e to the I 2 pi ft, plug into this LTI system, it has to come out as H of f times e to the I 2 pi ft. If you were given what the situation between input u and the output y is, let's say the difference equation, why not? You can then just plug it in, solve for h of f, and get h of f. The other way, if you are given h of t, you have h of t, find the Fourier transform of h of t, which is h of f. Okay? So once you have u as some constants times e to the I somethings, then you have h of f, y of t is hf times the a sub k, or u of f if the system is not periodic, times e to the I 2 pi ft. Yeah? And dt. df. Thank you. Yeah? So in step 1, if u of t is periodic, then you'll get Fourier series coefficients. And then this will be the sum for k equals minus infinity to infinity. And if it's not periodic, then it'll be integral from minus infinity to infinity h f u f e to the I 2 pi f t df.
There's a k at the top of the right. Okay.
Thank you. Thank you. Okay? The entire second half of Dr. Miller's section is, can I write a signal as periodic signals, a sum of periodic signals? Then, what is the output? The output is just those sum of signals modified by the system frequency response. The big picture of it, it's not that much that you have to know, but I guess you have to know a lot about all these little itty bitty things like how to do the integrals, how to add complex numbers. And that is what Hubert here is going to do about properties of Fourier transforms. Oh yeah.
Thank you very much. It's very good. Review.
Questions? Questions? Yes.
1 second.
So when you split up, say like you had cosine, yeah, you split it up into like your UR identity.
Yeah.
And then like each of positive I times one negative I times all that.
Can you pass it around? Thank you.
That is the one frequency.
Can you pass it around? Can you pass it around? Thank you. Where is it?
Let's come back to office hours for that.
Okay. Right now I'm distributing my notes, and while I clean the black, let's take like a 5 minutes break. So, and I'm sorry in advance. I won't finish in time, so you can leave anytime you want, as usual.